let's you and I talk about mathematics. I guess the FAA figures if you want to be an A&P and work on aircraft like this, you need to know something about mathematics. I think they're working on the theory that if you understand mathematics, you'll be more accurate, more precise. Basically, they might be working on the idea that figures don't lie. On the other hand, maybe they've forgotten an even more important principle, and that is liars can figure. Let's see if you and I can figure out mathematics. Now, mathematics is kind of the language of numbers. It's how we communicate about numbers. So let you and I lead off by talking about some terms. The first term we want to talk about is the term factor. We're going to say a number is used as a factor. What does that mean? Well, it means it's used in multiplication. If it's used as a factor, it's used in multiplication. For instance, they're going to say, what does the number 9 with a little 4 in the upper right-hand corner mean? Well, that means that 9 is raised to the 4th power, or 9 is used as a factor 4 times in multiplication. In other words, 9 times 9 times 9 times 9, using it 4 times, is 9 to the 4th power. And if you want to figure it out, you use your electronic calculator and you get an answer of 6,561 there. Using a number 3 times as a factor is expressed as 64 in this case, the number 64, with the 3 up there. That's 64 raised to the 3rd power. Another way of expressing that is 64 cubed. That's the cube of 64, and that's using 64 as a factor 3 times. In that case, it would be 64 times 64 times 64, or 262,144. All right, now they're also going to ask you, what is the square of a number? Well, that's raising a number to the 2nd power. For instance, here is 212 to the 2nd power, or 212 squared. That means the number is used as a factor 2 times. For instance, 212 times 212, the number is used as a factor 2 times. Multiply it out, the answer is 44,944, and that's 212 squared, or 212 raised to the 2nd power. Now, here comes a tricky one. What does 3 to the negative 4 power mean? 3 to the minus 4 power. Well, that means 3 is used to be as a factor 4 times, but it's 1 divided by 3 4 times. So it's 1 over 3 times 3 times 3 times 3. If you use your calculator, 3 times 3 times 3 times 3 is 81. And it means 1 divided by 81. So that's 3 to the minus 4 power. You're going to see that later on. Now they're going to ask you, what is the square root of a number? Well, the square root of a number is a smaller number that when it's multiplied by itself will produce a larger number. The square root of 1,746 you'd work out with your calculator. By the way, 1,746 to the 1/2 power is the same as the square root of 1,746. Now you and I are going to do this with our calculator, and we're going to get an answer of 41.7852. Let's do it. Here's 1,746. We'll just key that into the calculator. And notice right here, your calculator has a square root button. Now on the test, make sure you do go to the test with a calculator that does have a square root button, because it's going to make it a lot easier. So you just hit that square root button, and you find out the square root of 1,746 is 41.785. 7852, we called it here, and it's 41.7852. Now what that tells you is if you multiply 41.7852 times itself, you'll get 1746. And that means the square of 41.7852 is 1746, and the square root of 1746 is 41.7852. See, nothing to it. Now, another thing they can do to you is ask you the square root of kind of a big number, like what's the square root of 3,722.1835? Well, once again, it's just a little calculator problem. So if you take a look at the calculator, all you have to do is key in 3,722.1835, and then hit the square root button with that big finger there, and you get 61.0097. There you go, 61.0097. So all you have to do for square root is use the square root button. Nothing to it. Now let's take a look at a question they're going to ask you about square roots. They're going to say, take the number 8,019.0514, multiply it times 1 divided by 81, and that is equal to the square root of what number? Well, to solve this problem, the first thing we have to do is do what they tell you to do. Take this number and enter it into the calculator. It's 8,019.0514. And instead of multiplying times 1 divided by 81, all you have to do is divide by 81. That's the same thing, so divide by 81. And when you do that, you get the number 99.00634. They're going to ask you, that's the square root of what number? Well, to find out what it's the square root of, what you have to do is square it. And to do that, you multiply it times itself. On this calculator, all you have to do is hit the times button and the equal sign, and now you've squared it, and the answer is 9801.1255. Forget the 1255, and the answer is 9801. And that's all there is to it. To find the square of a number, you multiply it by itself. Now let's take a look at a question that's just a little more complicated. What they want you to do is figure out the square root of this expression. And the expression, of course, is a little complicated. It's minus 1776, it was a good year, by the way, divided by minus 2, and then when you get done doing that, you subtract 632, and when you get done with the whole thing, you'll take the square root of it. So let's resolve the things in the parentheses to begin with, and minus 1776 divided by minus 2 can be expressed as a fraction, and that's kind of handy. And then you subtract 632 from that, and then take the square root of that, and we'll have our answer. Okay, first of all, these minus signs actually cancel each other out. So if you want to use your calculator to do this, all you have to do is take 1776 divided by 2, and you find out that that expression works out to 888. So now it's 888 minus 632, so all we have to do is subtract 632, and we'll subtract that, and we get 256. Now they want to know the square root of this, so it's the square root of 256. So using your handy dandy calculator, all you have to do is hit the square root symbol and you get 16, and the correct answer is 16. So see, with this calculator, there's nothing to it. Now let's take a look at powers of 10. 10 is a magical number. We have a mathematics system based on 10. So a lot of things are very easy when you're dealing with the number 10 or 100 or 1,000. These are all powers of 10. For instance, 10 to the first power, 10 used as a factor once, and this makes sense, doesn't it, is 10. Now, 10 used as a factor twice is 10 to the second power, or 10 squared is another way to say that. And that's 10 times 10. That's 10 used as a factor twice, and you can see that that is 100. I think you're getting on to this. 10 to the third power is 10 times 10 times 10, and that's 1,000. Now, all you have to do then, as you can see, 10 to the fourth power is now 10,000. Just keep adding zeros. 10 times 10 times 10 times 10 is 10,000. So when you're working with tens and you increase the power, all you have to do is add a zero. You can see this is 10 to the 1 power, 2 powers, 3 powers, 4 powers. We just keep adding zeros. You can see it coming. 10 to the fifth power is 10 times 10 times 10 times 10 times 10. And that's 100,000. All we did was add a zero. And the last one, my favorite number, is 10 to the sixth power. And obviously, we got 6 tens here. And how many zeros do we have? Well, we know how many zeros are in a million, don't we? 6 zeros, and it's 1 million. 10 to the sixth power. So you can see when you're working with 10, and you increase the power by 1, all you have to do is add zeros. Now, let's take a look at 10 to the minus powers. We can start over again. 10 to the 1 is 10. Divide that by 10 and you reduce the power by 1. Each time you divide by 10, you reduce the power by 1. Multiply by 10, you increase the power by 1. So 10 to the 0 is 1. By the way, any number to the 0 power is 1. So 10 to the 0 is 1. 10 to the minus 1, now here's the fun part, is 1 divided by 10. It's written as 0.1. 10 to the minus 2 power is 1 divided by 10 times 10, or 1 divided by 100, and that's written as 0.01 or 1/100th. This is a tenth, this is a hundredth. 10 to the minus 3 power, you're getting onto this, is 10, 1 divided by 10 times 10 times 10. And notice the digit words that's important is the third one after the decimal point. First one after the decimal point, 10 to the minus 1. Second one after the decimal point, 10 to the minus 2. Third one after the decimal point, 10 to the minus 3, and that's 1,000th. 10 to the minus 4 is 1/10,000th, and the same thing is 1 divided by 10 times 10 times 10 times 10. 10, that's 1/10,000th. 10 to the minus 5 is 1 divided, and you do it 5 times. If you want to count up, it's the fifth number after the decimal point. 1, 2, 3, 4, 5. You got it, see, nothing to it. And finally, 10 to the minus 6 is 1 divided by 10, 1 divided by 10, 6 times, and it's 0.0000001, and that's the sixth number after the decimal point. Now, you're going to find that comes in extremely handy as we work around here. So let's take a look at the next question they're going to ask us about this. They're going to say the power of 10, which is equal to 1,000,000, is what? Well, if you go back to the table, the power of 10 that's equal to 1,000,000, here's 1,000,000, it has 6 zeros, and it's 10 to the 6th. So the power of 10 that's equal to 1,000,000 is 10 to the 6th. They're going to say, okay, what is the value of 10 raised to the negative 6th power? The value of 10 raised to the negative 6th power, that's 10 to the minus 6. And that is 10 to the 6th power is 0.0000001. And there it is right there. And you can see that it's easier to express that as 10 to the minus 6 than it is to write all those zeros down there. So that's what scientific notation is all about. That makes it easier to express numbers when you got lots of zeros in them. Now here's how you can use scientific notation. They're going to say to you, what is 16,300 equal to? And the answer is it's equal to 1.63 times 10 to the 4th power. Let's see if we can make some sense out of that. First of all, we'll start with the number 16,300. Then, if you remember, by the way, any number to the 0 power is equal to 1. So 10 to the 0 power is still 1. So 16,300 times 10 to the 0 means simply 16,300 times 1. The answer is still 16,300. So you can see now that this number is the same as this number. Now, if I divide this number by 10,000, I move the decimal point 4 places to the left. 1, 2, 3, 4. Then it becomes 1.63. But if I divide it by 10,000, I have to increase this number in order for the answer to still be the same by 10,000. So I just raise it 10 to the power of 4, and that's the same as multiplying that number by 10,000. So now 1.63 times 10 to the 4 is exactly equal to the same thing as 16,300. All I did is divide this part by 10,000 and multiply this part by 10,000, and it's the same thing. Well, when you get to very, very big numbers, this could be 10 to the 27, this makes it a very easy way to express it. So it's 1.63 times 10 to the 4, and that's equal to 16,300. Now, here's the case in which they're going to start off with scientific notation and ask you to translate it into English. So they're going to say the number 3.47 times 10 to the negative 4th power is equal to what? The answer is equal to 0.000347. All right, let's do it together. First of all, we have 3.47 times 10 to the minus 4. We're going to just express that just a little bit differently. It's the same thing. We'll just put some zeros here. 0.00347 times 10 to the minus 4. We just put some zeros there. You can see it's still the same thing. Now, let's divide one part of this by 10,000 and multiply another part by 10,000. To multiply by 10,000, you increase the exponent of a number by 4. So you take 10 to the minus 4, multiply it by 10,000, it becomes 10 to the 0. Of course, 10 to the 0, as you know, is 1, but it works out that way. All right? Now, since we've increased this to by 10,000 here, we'll have to divide this side by 10,000. So we'll take this decimal point and move it 4 places to the left. 1, 2, 3, 4. And that's easy to remember the 4, by the way, because we increased the exponent by 4, so we move the decimal point to the left by 4 to compensate for that. And we do that, and we get 0.000347, and 10 to the 0 is 1, so you can just forget that, and the number now is 0.000347. So anytime you want to increase a number by 10,000, you just raise the exponent by 4, or if you want to decrease a number by 10,000, move the decimal point 4 places to the left. By the way, that exponent by 4 only works if it's a power of 10. You can't do it with any other number. But if you want to increase 10 by 10,000, raise the exponent of the number 10 by 4. Now, here's another way they're going to ask you the same kind of question. They're going to say, what is the square root of 124.9924? I've never really wondered that a whole lot. And we'll do that with a calculator. And let's do it right now with a calculator and see what the square root of 124.9924 is. All you have to do is key in the number 124.9924. And then you use the square root button. Once again, you've got to have that square root button. And the answer is 11.18. So here we are. We find out the answer is 11.18. What's another way of expressing that? Well, let's take the calculator away for just a second. We'll take a look at another way of expressing that. And that is we'll take the 11.18, and they're going to say, is that equal to 1,118 times 10 to the negative 2nd power? Well, all you have to do, negative second power, is move the decimal point down 2. And so 11.18 times 10 to the 0 is what we start off with. Now, if you increase this by 100, multiply it by 100, you move the decimal point 2 places to the right. We do that. And you would also, if you do that, have to divide this by 100. All you do is lower, in the case of 10, the exponent by 2. So instead of 10 to the 0, it's 10 to the minus 2. And you can see that these two numbers are exactly the same. All we did here is move the decimal point 2 places to the right, and therefore we multiplied by 100. And to make this product come out to be the same, we have to divide this factor by 100. So we make it a minus 2, 10 to the minus 2 instead of 10 to the 0. And you can see it's exactly the same thing. So you're going to have to be pretty handy with your exponents of 10. But if you understand what we're doing right here, you got it made. All right, let's take a look at another example. They're going to say, all right, super mechanic, what is the square root of 1824? Well, the square root of 1824 is another one of those calculator problems. So let's you and I whip out the trusty old calculator. We'll punch in 1824, and then you hit the square root button, and you get 42.708. All right, now let's pull away the calculator and see what the rest of this question is. It's also equal to 0.42708 times 10 to the second power. How do we get that? Well, 42.708 times 1 is still the same thing, and 10 to 0 is 1, if you remember. And so if we want to make that equal to 0.42708, what we're going to have to do is move the decimal point 2 places to the left. That's dividing by 100. If you divide this side of the product by 100, you have to multiply this side by 100, and so that's what we did here. We took 10 to the 0 and raised it to 10 to the 2. That's adding 2 zeros to it, or multiplying by 100. And you can see once again, these two numbers are equal to each other. So you have to be able to recognize that on the written exam, and that's all they're asking for. Now, sometimes they'll combine taking square roots and raising powers all in the same question. Here's an example. They're going to say, what is the square root of 16 raised to the 4th power? Notice, who cares is not a correct answer on any of these. Not at all. All right. Let's take a look at it. First of all, let's use the calculator and find out the square root of 16. We'll enter 16, and then we'll hit the square root button. And the square root of 16 is 4. That happens to be 4 to the 1st power. We want to raise it to the 4th power. So we'll just multiply times 4, and that raises it to the 2nd power. And when we do that, it gets 16 to the 3rd power. We'll multiply by 4 again. And we get 64, and raise it to the 4th power, multiply by 4 again. And you should get 256 instead of, again, you do. So that's how you do it. You just simply work it out mathematically on a calculator. All you need to know is that 4 to the 4th power means multiply times 1. Multiply 4 is used 4 as a factor, I should say. It should be precise there. 1, 2, 3, 4 times. And that's exactly what we did. Let's take a look at another one they're going to do. Say, what is the square root of 4 raised to the 5th power? Well, once again, who cares is not a correct answer, but let's take a look at that on the calculator. Square root of 4 raised to the 5th power. All right, square root of 4, we'll punch in 4 to begin with, and then we'll use the square root button and find out the square root of 4 is 2. We might have known that to begin with, but what the heck. All right, now all we have to do is use that as a factor 5 times. We've used it once now, and so multiply times 2, and that's using it a factor a 2nd time, times 2 again, 3rd time, times 2 again is the 4th time, and times 2 again is the 5th time. And now we find out that the answer is 32. Remember, raising something to the 5th power is using it as a factor 5 times. We use 2 5 times, and we get 32. See, nothing to that either. All right, now they're going to ask you, what is the result of 7 raised to the 3rd power plus the square root of 39? Oh, no. All right, 7 raised to the 3rd power means you're using 7 3 times as a factor. So let's you and I use 7 3 times as a factor. And all we have to do is use the electronic calculator, punch in 7, multiply that times 7, and that's using it the 2nd time, multiply that times 7, and that's using it the 3rd time, and we get 343. So 7 as a factor, used as a factor 3 times is 343, and that's 7 raised to the 3rd power. Now we want to add that number, 343, to the square root of 39. So all you have to do is take your calculator and punch in 39, and take the square root of it, and we get 6.2449979. Now you keep that number and add 343 to it, and you get 349.24. That's the way you're going to do this on a test. So if you just have an electronic calculator with you and understand the language, and that's all we're talking about here is the language, and if you understand that, you got it made. All right, now let's talk about something simple, very similar, converting fractions to decimals. First of all, the decimal, which is most nearly equal to a bend radius of 31/64 is what? All you have to do to solve this problem is take your electronic calculator and divide 31 by 64. So punch in 31, divide by 64, and you find out the decimal is 0.4837. So let's take a look at that answer up there, and we got it right, 0.48437, I should say, 0.48437. All right, now they're going to say, let's take a look at another one. The radius of a piece of round stock is 7/32. Now the decimal, which most is nearly equal to the diameter, is what? Well, first of all, let's take 2 times 7/32, and you multiply the numerator by 2. Don't leave the denominator alone, and that becomes 14/32. Now, all you have to do, because we're using diameter, remember the diameter is twice the radius. So the diameter is all the way across, radius is halfway across. And so now we have 14 divided by 32. All we have to do is use the electronic calculator to do that. So let's you and I take the electronic calculator, punch in 14, then divide by 32, and you should get 0.4375, and son of a gun, we did. We got 0.4375. Now let's take a look at an exercise involving adding fractions. And the thing you need to know about adding fractions is anytime you add fractions together, you have to have the denominator the same. Here's the question. The decimal, which is equal to the mixed number 1 in 7/32, is what? Well, let's do it. First of all, we'll have to take the 1 and add it to the 7/32. You can't do that. So let's make 1 a fraction. And you do that, it becomes 32/32. That's equal to 1. And once again, it has to be in 30 seconds because to add fractions together, the denominator, the bottom half, has to be the same. So you take the 32/32 and add it to 7/32, and you get 39/32. Now notice the big numbers on top. That's called an improper fraction. But don't worry about it. We're going to keep it that way. Now, all we have to do is use the electronic calculator, divide 39 by 32 to find out what the answer is going to be. And when you do that, you divide 39 by 32, and you get 1.2188, or 875. We rounded it off to 88. All right, so to add fractions together, you have to have the denominator the same. All right, let's take a look at another question. The decimal, which is most nearly equal to 77/64, is what? That's real simple. We've done it before, but let's do it again real quick. Use the electronic calculator. Divide 77 by 64. That's what a fraction tells you to do, is divide. And when you do that, you get 1.203125, and we rounded it off and got 1.2031, and that's what they got on the test. All right, now, the decimal equivalent of the fraction 43/32 is what? Now, that's once again called an improper fraction. No problem. All you have to do is whip out your trusty old calculator and divide. So let's do that real quickly. And it simply says divide 43 by 32. So you do that real quickly with your calculator. And when you do that, you get 1.34375. And there we got it right there. Now let's take a look at another question. Here they say which fraction is equal to 0.025. So what they've done in this case is they've given you a decimal and they ask you which of these fractions is equal to that decimal. Well, it's pretty easy. You can use your calculator and just do exactly what it says to do. For instance, let's take a look at A here. It says 1 divided by 4. That's what that fraction tells you. So you use your calculator and do 1 divided by 4 and you get 0.25. Well, it's close, but it's no cigar. So let's do what B tells us to do. And that's 1 divided by 400, and 1 divided by 400, and I get 0.0025. Still doesn't work. I'm going to guess that 1 divided by 40 is the answer, so let's do that, and we get 0.025. So the answer is just do what the fraction tells you to do until you get the decimal you're looking for. Let's do another one. We'll make it a little bit more complicated on this one. It says, what is the fractional equivalent for a 0.0625 thick sheet of aluminum? Well, once again, all we have to do is do what it says to do. So let's use the calculator, and we'll do 1 divided by 32, and we get 0.03125. That's not a correct answer. We're looking for 0.025. 0.0625. Now we'll do 3 divided by 64, and son of a gun, we get 0.046875. Well, that's not it. I'm going to bet the last one is. 1 divided by 16, and you get 0.0625, and that is the correct answer. So once again, just do what the fractions tell you to do with your calculator. Let's do one more, and this one is a little bit more complicated yet. It says a blueprint shows a hole of 0.171875 to be drilled. Which fraction size drill bit is most equal? Well, boy, that's a big number, but let's take a look at it and see what we can do. Let's do, first of all, 11 divided by 64, and bingo, we hit it right off. It's 0.171875, and we got it exactly correct. So in this case, all you had to do is divide 11 by 64, and you got it. Now let's talk about solving equations. They're going to ask you a few questions on the FAA written exam about solving equations. Some rules of thumb will be helpful for you here. First of all, use a calculator. You'd be surprised how much sharper your calculator is after taking the written exam for a while than your brain is. All right, let's get some rules about multiplying with plus and minus signs. To review this, you might remember if you multiply a plus times a plus, the answer is a plus. A minus times a minus, the answer is still a plus. How about a plus times a minus? Then the answer is a minus. All right, now let's take a look at an equation, and there's one other thing I need to tell you, is when you have an addition inside brackets or parentheses, you've got to get rid of that addition or subtraction before you can multiply. So the first thing you do is get rid of these parentheses. Let's take a look at how we're going to do this in an actual case. We'll take a look at this question right here. First of all, it says 4 minus 3 times the bracket or the quantity minus 6 times 2 plus 3, quantity closed, plus 4, quantity closed again. How about that? All right, now here's what we have to do. Let's get rid of everything inside the quantities first. So we'll leave the 4 minus 3. That stays the same. But let's take this 2 plus 3 and add them together, and that makes it 5. Okay, and then that's how we finish off this right here. Now let's continue, and let's get rid of the next bracket. So the next bracket is minus 6 times 5. That's 30. So now we have 4 minus 3 times the quantity, 30 plus 4. You see, we're resolving all the things into brackets. Now let's take a look at the minus 30 plus 4. What are we going to do with that? Well, just add them together algebraically, and that comes out to minus 26. So we now have 4 minus 3 times minus 26. Now we can multiply that minus 3 times minus 26. What's a minus times a minus? You're right, it's a plus. So it becomes 4 plus, and 3 times 26, 3 times 6 is 18, 3 times 2 is 6, carry the 1 is 78. So it's 4 plus 78, and we can do this one in our head. We don't need the calculator for it, but 4 plus 78 equals 82. So that's how we do it. We're going to just take a look at all the brackets and get rid of the brackets before we multiply anything. Let's do another one. Make sure we understand what we're talking about here. Let's make sure I understand what we're talking about anyway. Okay, here we have minus 6 times the quantity, minus 9 times the quantity, minus 8 plus 4, quantity closed, minus 2 times the quantity, 7 plus 3, quantity closed, and quantity closed again. Oh, how about that for complicated? All right, all we have to do now is get rid of the quantities. So minus 8 plus 4 becomes minus 4. We took that down, squeeze it down to that right there. All right, let's take a look at the next thing we can get rid of. 7 plus 3 becomes 10. So now it becomes minus 6 times the quantity minus 9 times the quantity minus 4, quantity closed, minus 2 times the quantity 10, and quantity closed again, and quantity closed again after that. All right, now let's get rid of the brackets again here. We've got brackets here. So what's minus 4 times minus 9, or minus 9 times minus 4? Well, once again, a minus times a minus is a plus, so that becomes plus 36. 4 times 9 is 36. Minus 2 times 10 becomes minus 20, because a minus times a plus is a minus, so that's minus 20. So now we have 36, 6 times the quantity, 36 minus 20. Quantity closed. Now let's get rid of the brackets here. What's 36 minus 20? You got it, 16. So it's minus 6 times 16. And this time, let's use the electronic calculator. I don't want to get too carried away. So it's minus 6 times 16 equals minus 96. See? Nothing to it. It's all too easy for everybody. I can see that right now. So let's you and I do another one. First of all, we got brackets around this whole expression here, and it's divided by 2. And then inside here it says the quantity 4 times minus 3 plus the quantity minus 9 times plus 2. All right, now the first thing you and I would like to do to make this easy, let's simplify things by getting rid of these brackets, because this whole expression is divided by 2, so all we have to do is put this whole expression over 2, and we got the same thing done right there. That way we got rid of the brackets and simplified it. Now, next, let's get rid of the things inside the parentheses. So what's 4 times minus 3? Well, 4 times 3 is 12, and a plus times a minus is a minus, so that becomes minus 12 inside the brackets there. And let's squeeze this one down. That's minus 9 times 2. That's obviously minus 18. So we now have minus 12 plus minus 18. Well, it's minus 12 and minus 18. That becomes minus 30, and it's all divided by 2. So minus 30 divided by 2, and you can do this one in your head, comes out to minus 15. So once again, you can see the trick to all of these equations is going to be get rid of the brackets first. That's all there is to it. Let's do another one. First of all, this one looks like this. It's 64 times 3/8 divided by 3/4. Now, what they want you to know here is what do you do when you have to divide with a fraction? Well, what you do, let's rewrite this, by the way. It's really 64 over 1, because we want to make these all fractions. That's what we're trying to do here. Times 3/8, and it's still divided by 3/4. Now, 64 over 1 times 3/8, everything stays the same. But to divide by 3/4, what do? You multiply times 4/3. Just flip this thing around and make it 4/3, and now you can multiply. That's easy, isn't it? All right. Now, let's take a look at what we did here. We have a 64 and an 8. You can divide both of these. You can divide, by the way, the top and bottom of all this, and it comes out the same. So to simplify it, we divide by 8. 8 divided by 8 is 1. 64 divided by 8 is 8. And now we have 8 over 1 times 3 over 1 times 4 divided by 3. And by the way, look at this. I got a 3 here and a 3 here. I could divide by 3 in each of those. And let's take a look further down and see what we have next. And son of a gun, when we got rid of the 3's, now it becomes 8 times 4, because the 3 is gone. And 4 times 8 is what? 32. Nothing to it. Just as easy. It's duck soup. All right, let's do one more yet along here and see what we get this time. And this time we get 32 times 3/8 divided by 1/6. You got it. Let's make them all fractions. 32 over 1 times 3/8, still divided by 1/6. What are we going to do with that division? You've got it. Flip it. Now it's 32 over 1 times 3/8, this time times 6 over 1. Now we can get rid of a few things. Let's take a look at it. First of all, I see right off here we have an 8 and a 32. We could divide each of those by 8. And the 8 becomes 1. The 32 becomes 4 when you're divided by 8. So now we have 4 times 3 times 6. And 4 times 3 is 12, and times 6 is 72. And the correct answer is 72. Now, here's another kind of question they ask you, and it looks a little complicated at first, but when you work it out, it's really pretty simple. What they're going to do is give you this expression you have here at the top, and they're going to say, what does that equal to? Well, the rule of thumb is whenever you have an expression like this with parentheses in it, you do what's in the parentheses first. So what we're going to do is keep simplifying this expression and get the answer. So, first of all, it says 1/2 times the quantity minus 30 plus 34, and then you take that and multiply it times 5. So we can express the 1/2 as a fraction, 1 divided by 2, and that's times the quantity minus 30 plus 34 times 5. And now we can simplify this expression here. Minus 30 plus 34 comes out, you can do that in your head, it's 34 minus 30 comes out to 4. So it's 1/2 now times 4, and then times 5. So 1/2 of 4 is 2, so now we're down to 2 times 5, and the correct answer is 10. So when you simplify the expression inside the parentheses first, it all falls into place for you. Well, that was too easy for everybody, so let's just do another one. This one says take the quantity minus 3 plus 2 times the quantity minus 12 minus 4 plus the quantity minus 4 plus 6, and then multiply that times 3. And what does that equal to? Well, let's take a look at it. We're going to do what's inside the parentheses first. So minus 3 plus 2 comes out to, well, that's minus 3 plus 2, that's minus 1. And minus 12 and minus 4 comes out to minus 16. You add them together in that case. And minus 4 plus 6, well, it's 6 minus 4. That came out to 2. I knew that one easily. And then the next one just says 3, so we'll just copy the 3 down. And that's times 3.
Now, we have minus 16, minus 1 times minus 16. Well, the minuses cancel out, and that becomes just plain old 16. And then we have 2 times 3, so we can put that together. And now we have 16, and 2 times 3 comes out to 6, so it's 16 plus 6, and we get 22. I told you it was another easy one, so let's do one more. And we can make it a little bit more complicated, and boy, I don't know, maybe a lot more complicated. They give you brackets, and they say the square root of 100 plus the square root of 36 minus the square root of 16. Well, once again, what you want to do in this case is simplify the square roots before you do anything else. So we might use a calculator for this. We can take the square root of 100, so all we have to do is put in 100 and hit the square root button, and the answer is 10. You might have known that in your head, but why not use the calculator? Then we'll do the square root of 36, so put in 36 and hit the square root button, and you get 6. Once again, you might have known that in your head. And then the square root of 16, put in 16, hit the square root button, and you get 4. So now this resolves down to 10 plus 6 minus 4. Well, 10 plus 6 is 16, but we can do that in the calculator, 10 plus 6. And then we'll subtract 4. We'll do minus 4, and the answer is 12, and we figured it out. You know, really, they don't get much simpler than this, do they?
All right, you guys are getting this down, so let's complicate it up just a little bit by taking a look at a more complicated way the FA asks you questions about this on the test. First of all, you'll have 125 divided by minus 4. And by the way, that is a division symbol. It looks like square root. Don't confuse it with square root. It's regular old long division. And that's all divided by minus 36 divided by minus 6. Now, how are we going to deal with this? Well, we're going to turn them into fractions. That's what we're going to do, because 125 divided by minus 4 could be expressed just like this, 125 over minus 4. And that's all divided by, so we'll put a division symbol here, by minus 36 divided by minus 6. We'll express that as minus 36 over minus 6. All right, now, what do when you want to multiply instead of divide by a fraction? You flip it. So this minus 36 over minus 6 becomes, divided by, becomes times minus 6 over minus 36. We flipped it around. Nothing to it. All right, now, let's see what we can do with this. Here I see I can divide minus 6 by 6, and I would get minus 1, and minus 36 by 6, I get minus 6. So we can simplify that fraction, and it becomes minus 1 over minus 6. Now we have 125 divided by minus 4 times minus 1 divided by minus 6. Well, you can multiply this out. 125 times minus 1 is minus 125. Minus 4 times minus 6 becomes plus 24. I think it's calculator time, don't you? Let's whip out that trusty old calculator and take minus 125 divided by 24. And when you do that, you get minus 5.20, and that's what they have on the test, and you and I got it figured out. So if you see that division symbol, just treat it like division. It's not square root, it's just regular old long division. Isn't this fun? Isn't this about the most exciting thing you've done in a long time? Well, this time let's you and I do an easy one. This has been too much work for me. Here we have a simple one with just lots of parentheses in it. Let's take a look at it. It's minus 3 plus 2, that's a quantity, times the quantity minus 12 minus 4, plus the quantity minus 4 plus 6, times that quantity is times 2. Once again, all we have to do here is eliminate the things inside the parentheses. So let's do it. Minus 3 plus 2, you add that together, and that comes out to minus 1. You guys got it. Minus 12 minus 4 comes out to minus 16. Let's see now. Minus 4 plus 6 comes out to plus 2, and that's times 2. And we have now the quantity minus 1 times the quantity minus 16 plus the 2 times 2. All right, let's take a look at it. First of all, a minus times a minus is a plus, so this becomes plus 16. And 2 times 2, back in the old days, that used to be 4. I think it still is, so we'll call that 4. So 16 plus 4 equals 20. I told you it was an easy one. Let's do another one. Now, it is really very likely that somewhere in the middle of this test, you're going to get the feeling that the people who write the FA written exams are staying up nights to make your life complicated. Well, if you do get that feeling, here is where you're likely to get it, because they're going to give you an equation that looks like this. We're talking complicated, folks, and they're going to say, okay, super mechanic, give us an answer to this thing. Well, folks, it's not as complicated as it looks, because all you have to do is resolve the parentheses and then work down to an answer, use your electronic calculator when you need to, and it's going to all fall into place for you. Let's take a look at how easy it will fall into place for you. First of all, we have minus 5 plus 23. Well, if you want to resolve that, all you have to do is do what it says. It's 23 minus 5, and that comes down to 18. So we resolve the first expression right there. Then we have minus 2, so all we have to do is bring that down. Now you have 18 times minus 2. And then here is where they are trying to make your life complicated. They have 3 to the minus 3 power. Well, you know, because you took the King course, that anything to the minus power is 1 over that number, so it's really 1 over 3 to the third power. Well, 3 to the first power is 3, 3 to the second power is 3 times 3, and 3 to the third power is 3 times 3 times 3, and that's all there is to it. It becomes 1 over 3 times 3 times 3. Really very simple when you get right down to it. And you're going to multiply that times the square root of 64. Well, if you remember your squares and square root, you know that 8 times 8 is 64. So therefore, the square root of 64 comes down to 8. And so you wind up with this expression, all divided by minus 27 divided by 9. Well, all we have to do is take 27 by 9, divided by 9, which comes out to 3, and put a minus sign in front of it, becomes minus 3. So now we have resolved the expression at the first level. Let's take it down another level. Now we have 18 times minus 2. Well, 2 times 18 is 36. Since it's minus 2, it becomes minus 36. And then we have this 8, so we'll put the 8 up here. 8 times 1, so we have an 8. Divided by 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27, so that becomes 8 divided by 27, and all of that is divided by minus 3. So here we are there. Now, all we have to do at this point is go down another step. It's minus 36, and it's going to be plus 8 divided by 27. Hold the phone. I'm stopped right there. I can't do 8 divided by 27 in my head, so let's whip out the trusty old magic electronic calculator, and let's key in 8 divided by 27. And when you do that, you get an answer of 0.2962. Well, we don't need all of that about, we'll say 3 decimal places will take care of it for us, so it becomes 0.296. So if you take away the calculator and look underneath there, it becomes minus 36 plus 0.296, and all that's divided by minus 3. Now, all we have to do is take minus 36 plus 0.296. Once again, I'm going to need the electronic calculator for that. So it's minus 36 plus, and we'll make that a minus there, plus 0.296. And when you do that, you get 35.704. So let's take a look at that. You get 35.704 divided by minus 3. And now to solve that problem, all we have to do is take, it's minus 35.704 divided by minus 3, so we'll divide that by minus 3, and we've got the answer to the equation. And the answer is 11.9, and that's what they have on the test, 11.9. And you can see there is nothing to it. And probably the trickiest thing to this whole thing was 3 to the minus 3 power, and you figured that out. Resolve the parentheses, use your electronic calculator, and it all makes sense. All right, let's do another one. This one involves quite a few square roots. And so here we are, the square root. And by the way, notice the difference between the square root symbol. It kind of has a check in the front of it, and a division symbol is a straight line here, so they're different from each other. Here's the square root of 31 plus the square root of 43 divided by 17 squared. Well, there's no way I can do this without my electronic calculator. So let's whip out that electronic calculator and do the square root of 31. So we'll punch in 31 and then use the square root button, and we get 5.567. If we move this up, we can see that we've got that there, 5.5678. All right, the next thing we want to do is find out the square root of 43. So let's punch in 43 and hit the square root of that, and we get 6.5574, so that's good enough. Now, the next thing we need to do is figure out the bottom, which was 17 squared. So let's take 17 times 17, and 17 times 17 is 17 squared, and that's 289. So let's take a look at this without the calculator for just a second. We've got this number plus this number divided by this number, which is 289. So let's take the calculator again and add these two numbers together. That ought to be easy enough. So we take the 5.5678 It's a magic finger there, isn't it? Plus 6.5574. And we get 12.1252. We can divide that by 289. And we get 0.04195, and that's all there is to it. So when you get to the complicated math like that, don't let it confuse you. Just whip out your trusty old calculator and things will fall into place for you. Now, occasionally you need to come into the FA written exam with some information already in your head. Here's a case in point coming up. Right here we have a symbol that looks like 2 Roman columns. That is not 2 Roman columns. That's the capital symbol for pi. And pi is, as you remember, used in the formula for a circle, and it's 3.1416. We'll talk more about that later on. If you have any trouble remembering it, 3.1416, I guess you have 3 times the trouble if you have a 14-year-old and a 16-year-old in the family at the same time. I'm sorry, that's the best I can do on it. Anyway, pi is 3.1416. We'll use that later on. Now let's you and I take a look at the question they're asking us to solve in this particular case. It's the quantity minus 35 plus 25 times the quantity of minus 7 plus pi times the quantity 16 to the minus 2. Never fear, you and I know what to do with that, so let's go ahead and solve this problem by resolving the things inside the parentheses. So we'll do that. By the way, all that's divided by the square root of 25. So you take all of this and divide it by the square root of 25. Now let you and I get the parentheses all together. Here's minus 35 and plus 25. You add those two together algebraically, and that comes out to minus 10. So here we have minus 10. We'll just bring down the minus 7, so it becomes minus 10 times minus 7, plus pi. And we'll just substitute the number 3.1416 for that mathematical symbol up there. And so you write that in, 3.1416 times 16 to the minus 2. What is that? That's 1 over 16 squared. And 16 squared is 16 times 16. So it's 1 over 16 times 16. And it's all divided by, if you remember, the square root of 25. I can do that one in my head. The square root of 25 is 5. 5 times 5 is 25. Now, if you cannot do it in your head, never fear. Just use your electronic calculator and use the square root function. You'll find out the square root of 25 is 5. Okay, so the square root of 25 is 5, so all that's over 5. Now, let's take a look at it and see if we can resolve this down. We can multiply the minus 10 times the minus 7. By the way, a minus times a minus is a plus, so that comes out to 70. Bring the pi down, that's plus 3.1416. And now we have 1 divided by 256. I can't do that one in my head. Let's you and I use the calculator. Okay, it's 1 divided by 256. And when you do that, you get 0.0039 and some other numbers over there. We'll just leave that off. We'll stop at 0.0039. And so now we have 3.1416. We can take the calculator away, if you will. 3.1416 times 0.0039. And so now what we're going to need to do is multiply these two times each other. So let you and I go ahead and do that. And it's we'll do 3.1416 times 0.0039, and we get 0.01225. And all of that's divided by 5. All right, now let's take a look at it. We'll use it 0.0123. We'll just use that. Now let's take the calculator away for just a second. Take a look at this again. It's 70 plus 0.0123 divided by 5. Now, all we have to do, and by the way, let me show you a little trick. 70 divided by 5 is 14, and this is such a small number, by the time it gets divided by 5, it's not going to matter too much. So we know the answer is going to be very close to 14, but let's you and I use the calculator and figure out the exact answer. It's 70 plus 0.0123 divided by 5, and I was right. It came very close to 14, 14.00. We can even forget these other numbers, and the correct answer on the test is 14. So once again, when you see in a test that you have a very small number and it gets divided by another number, that's going to be so small it's probably insignificant. So it's really 70 divided by 5. Now let's take a look at figure 52. Here the FA is saying to you, all right, super mechanic, you think you understand equations, don't you? Well, take a look at this. And when you get there, you say, holy mackerel. I'll tell you what, we're going to make this look simple because it really is simple. Here's the way it goes. First of all, they're saying take the square root of this entire mess. And underneath that square root, you get the quantity minus 4 to the 0 power plus 6 plus this quantity, which is the fourth root of 1296, and you multiply that times this quantity, which is the square root of 3, quantity squared. Never fear. We can simplify this a lot. Let's start and do it now. First of all, we have the quantity minus 4 to the 0 power. Now let's go back just a little bit. We said 10 to the third power is 1,000. 10 to the second power is 100. To get from the third power to the second power, you divide it by 10. 10 to the first power is 10. You keep dividing by 10. And 10 to the 0 power works out to be 1. In fact, any number to the 0 power works out to be 1. So all we have to do is put a 1 down here, because any number, the quantity minus 4 or any other number to the 0 power is equal to 1. Once you know that, that just went away that easily. Now, we'll just copy the 6 down here. Now we're asking you the question, what number used as a factor 4 times is equal to 1296? That's what the fourth root of 1296 means. Now we're looking for that number that's used as a factor 4 times to get 1296. Well, you could use 1 as a factor 4 times. You still get 1, so we know it's a bigger number than 1. You could use 10 as a factor 4 times. You get 10,000. So it's somewhere in between 1 and 10, because 10,000 is bigger than 1296. Let's use 5 as a factor 4 times and see what that gets us. Maybe that's the answer. So 5 times 5 times 5 times 5 is 625. So it's a bigger number than 5. Let's try 6. Let's use 6 as a factor 4 times to see what we get. 6 times 6 times 6 times 6, and son of a gun, that's the answer, 1296. 6, when used as a factor 4 times, comes out to 1296, and they're asking you what is that number, and the answer is 6, and that's all there is to it. Now over here they're saying take the quantity of the square root of 3 and square that. Now what they're telling you to do here is take 3, find the square root of it, and then square it. Well, wait a minute. If you did that, wouldn't you be right back to 3 again? And the answer is yes, you would. If you take the square root of 3 and then square that, you're right back to 3 again, so that's 3. So now all we have is the square root of the entire mess, 1 plus 6 times 3. Well, we can do 6 times 3 right now. That's 18. So it's the square root of 1 plus 6 plus 18. Well, 18 and 6 is 24 and 1 is 25. So the real question is, what is the square root of 25? And if you can't do it in your head, you can play around with your calculator, but 5 times 5 is 25. And the correct answer to this equation is 5. And that's all there is to this entire mess. What they're going to say to you is, okay, you want to be a mechanic? Then go to figure 55. Then they're going to show you this triangle with these dimensions. And it's 4 inches this way and 3 inches that way, and they're going to ask you, what is the area of this triangle? Well, it's 1/2 of the base times the height, or 1/2 of 4 inches times 3 inches. 4 times 3 is 12, and so 12 divided by 2, because we're doing half of that, becomes out to 6 square inches. So the area of this triangle, you and I just worked it out, and this is an FAA test question we just now did, is 6 square inches. All right, let's take a look at another one. They're going to say, all right, let's assume you have a triangle defined by points A, B, and C. I believe it is on the test, A, B, and C. That's this triangle up in here. And they give you the dimensions. A to B is 7.5 inches. So A to B up here is 7.5 inches. That's either the height or the length, however you want to do it. And the other dimension they tell you, A to D, and A to D down here is 16.8 inches. By the way, if A to D is 16.8 inches, B to C is also 16.8 inches. So all you have to do is take 1/2 of 16.8 times 7.5 and see what you get. Well, let's you and I whip out the trusty old calculator and see if we can figure that out. And first of all, if you multiply those numbers by each other, 16.8 times 7.5, you'll get 126. Now divide that by 2, because you're 126 divided by 2. And you found out the answer to this question is 63 square inches. That's exactly how they're going to ask you questions about this on the FAA written exam. Obviously too easy for everybody, so let's you and I take a look at a trapezoid. Now this is a trapezoid. Now a trapezoid, as you can see, looks an awful lot like a rectangle. Only on a rectangle, the sides are parallel and top and bottom are parallel. But in a trapezoid, only the bases are parallel and the sides are not parallel. So you can't find the area quite as easily. If you remember in a rectangle, the area is base times height. Well, if you could average out these bases and multiply it times the height, then you'd have the area of a trapezoid. And that is exactly how you find the area of a trapezoid. Let's take a look at the formula for an area of a trapezoid. What you do is you take the height, and that's just 5 inches in this particular case, times 1/2 the sum of the bases. Well, 1/2 the sum of the bases is the average of the bases, so nothing to it. All right, so the height in this particular case is 5 feet, and the bases are 12 feet and 9 feet. Add those together, 12 feet plus 9 feet, and multiply it times 1/2, and that's the average base. Well, 12 plus 9 is 21. Take half of that, and that's 10 1/2. So 5 feet times 10 1/2 gives you the area of this trapezoid, which is 52 1/2 square feet. Let's do another one. Let's take a look at this one right here that we're going to have, and this one has a height of 2 feet and a base of 6 feet and 4 feet. And let's take a look at the numbers for this. All we have to do is take that 2 feet times 1/2 of the sum of the bases. 6 plus 4 is 10. 1/2 of 10 is 5. And so we'll take 2 times 5, and it's 10 square feet right here. So the area of this trapezoid is 10 square feet.
Now here's a question they're going to ask you that requires you know the definition of a cube. Holy mackerel, you might have known it once, but do you know it now? Well, you might remember that a cube is a solid shape in which every surface is a square. So each one of these surfaces is a square. Now, how many surfaces are there in a cube? Well, let's count. There's one at the back here, 2, 3, 4, one at the bottom, 5, one at the top, 6. So there are 6 squares in a cube. Now, what you need to know is they're going to ask you a question that goes like this. They're going to say, what is the entire surface area of this cube where one edge is 7.25 inches? Well, all the edges are the same, so it's going to be 6 times length times the width. So, or length times width are the same in this case, so it's 6 times the length times the width. Now, let's put some numbers in here. It's going to be 6 times 7.25, and these are equal, times 7.25. 6 times 7.25 times 7.25. Well, now, all we have to do is get the calculator out, and we'll take 7.25 times 7.25, and we get an answer for that, which we don't particularly care about. It's 52 and something or other, and multiply that times 6, and we find out that the total surface area of this cube is 315.375 square inches.
All right, now let's take a look at fuel tanks. They're going to give you rectangular shaped fuel tanks, as they call it on the FAA written exam. And so the volume of any shape like this is like this. Let's take a look at the formula for it. The volume is the length times the width times the depth. So all we have to do is know those numbers for this particular tank, and we'll find out how many cubic inches are in the tank. Well, in this particular tank, it's 37.5 inches times 14 inches times 8.5. There they are. 37.5 this way times 14 times, actually it's 8 1/4. I said 8.5. I lied about that. It's 8 1/4. And so they're going to give it to you as 8 1/4 inches, and they're going to give it to you as 37.5 inches. To make it easy, translate that 37.5 into 37.5. They're going to give it to you as 14, so that's easy enough. Translate the 8 1/4 to 8.25, like so. See there? All right, now all you have to do is use your electronic calculator. So let's you and I whip out the electronic calculator and do this. 37.5 times 14 times 8.25, and you get 4,331.25 cubic inches, and that's the volume of that particular fuel tank right there. All right, now let's take a look at another way they're going to ask you questions about this. They're going to say, you have a fuel tank that has these dimensions, and this is 12 inches times 30 inches times 60 inches, and they're going to ask you how many cubic feet are in the tank. Well, an easy way to do this is to convert all of these into cubic feet to begin with. Let's take a look at it. All right, 60 inches, and there's 12 inches in the cubic feet, so it's 60 divided by 12 times 30 divided by 12, because once again, there's still inches, it's 12 inches in a foot, times 12 divided by 12. Now let's make each of these divisions before we multiply. 60 divided by 12, you can do that in your head, that's 5. And 30 divided by 12, let's you and I get out the electronic calculator to do that. 30 divided by 12, 30 divided by 12 equals 2.5. So that's 2.5 feet. 12 by 12, I can do that in my head, that's 1 foot. So now let's use the electronic calculator and multiply 5 times 2.5 times 1. You don't even need to use the 1 because it's assumed anyway. And the volume of this is 12.5 cubic feet. Let's take a look at another fuel tank. This time they give you a fuel tank that they tell you that is rectangular shaped, and they tell you that the tank measures 27.5 inches in length, and so we have that right there. 3/4 of a foot
in width. Now, they're trying to confuse you here because in order to solve this problem, we have to have all the dimensions to be in the same units. Here we have inches, over here we have feet, so we're going to eventually have to convert this feet or foot into inches, and we'll do that just a little bit. And they'll also tell you that it's 8 1/4 inches in depth. So now you have the dimensions of the tank. Now, what they're going to ask you is how many gallons will the tank contain? And then they'll tell you that there are 231 cubic inches per gallon. So the first thing we're going to have to do is figure out how many cubic inches we have here, figure out the volume of the tank, divide by 231, and that'll tell us how many gallons. Now, you don't have to memorize the 231. They gave you that in the problem. So let's take a look at it. The first thing we need to do is convert this 3/4 of a foot to inches, and that's pretty simple. All we have to do is take 3 divided by 4 times 12, and we get 9 inches. So we have 9 inches instead of 3/4 of a foot. So now all we have to do to find the volume is multiply all the dimensions times each other. So we'll take that 9 times, and it was 27.5, we'll call that 27.5, and it was 8 1/4, we'll call that 8.25, and multiply all that out, and we get done doing that, and we find out we have 2,041 cubic inches in this tank. And they told us in the question that 1 gallon is 231 cubic inches. So divide by 231, and now we'll find out how many gallons we have, and we have 8.8 gallons. Now, here's another number that I think will make things easy for you in the test, and that is if you know that 1 cubic foot is equal to 7.5 gallons, and you want to know how many gallons a tank will hold, all you have to do is find out how many cubic feet are in that tank, multiply it times 7.5 gallons. Let's take a look at some numbers, the way the FAA is going to give them to you on the test. They're going to give you a tank that has dimensions of 2 feet by 3 feet by 1 foot, 8 inches. Now, let's keep all the dimensions in feet instead of going to inches, and we'll make things simpler. So let's take a look at those numbers again. First of all, remember that 1 cubic foot is equal to 7.5 gallons. And our tank was 3 feet by 2 feet, but hold the phone. We had 1 foot, 8 inches. Well, there's 12 inches in a foot, so let's call that 1 foot, 8 inches, 20 inches. First of all, this foot is 12 inches, and add 8 more inches makes 20 inches. Divide by 12 again, and you're back to feet. So we have 20 inches divided by 12, and that keeps it in feet. It's 20/12 feet. So all we have to do is multiply this out with the electronic calculator, and we can find out how many cubic feet are in this tank. So we take the 3 times 2 times 20, divided by 12, and we find out that's 10 cubic feet. Now, 1 cubic foot was 7.5 gallons, so multiply that times 7.5, so 10 times 7.5, and you find out that tank holds 75 gallons. You could see it coming. All right, here's one more question about fuel tanks you need to know. They're going to say select the container size that will be equal in volume to 60 gallons of fuel. Well, 60 gallons, and we know that 7.5 gallons is 1 cubic feet. So you take 60 gallons divided by 7.5, and you get 8 cubic feet. Now this time, let's you and I make a cylinder out of this piece of sheet metal. Let's assume the piece of sheet metal is 20 inches tall. Now the question we're going to ask is, how wide a piece of sheet metal do we have to make the cylinder? Let's you and I take a look at the cylinder we're going to make. We're going to make a cylinder by wrapping the sheet metal around, and we want the cylinder to have 8 inches of diameter. We want it to be 20 inches tall. Well, the question is, if we want 8 inches diameter, how much sheet metal do we have to use to do that, wrapping it around? Of course, what it is, we want a circumference that works out equal to 8 inches diameter. So what you and I have to know to do this is the formula for the circumference of a circle. We do know it. Here it is. The formula is pi times the diameter. All right, pi is 3.1416. You and I got that memorized earlier. And the diameter is 8 inches. So you take 3.1416 times that diameter of 8 inches, and you and I know what the circumference has to be. Let's you and I whip out the trusty old calculator and do that. And here it comes, 3.1416. We'll key that into the calculator and multiply that times 8 inches, and we find out that we have 25.1328. Now, here is the tricky part of this question on the test. They're not going to give you this in decimals. They're going to give you 25 inches in so many fractions of an inch.
Now here are the answers they give you. First of all of the answers have 20 inches as that one dimension. And the other dimension will be 25 inches plus something or other. Now hold it. We got one with only 24 inches, so you know you can throw out answer B right off. Now if you were actually going to fabricate this thing, you would want to use just enough metal, but not too much. So we're looking for an answer that's over 25 inches and just the right length, which is 25.1328. So here's what we're looking for, 25.1328. And all we have to do is figure out which one of these fractions, 9/64 or 5/32, comes to just over 0.1328, but not too far over. Well, let's use the electronic calculator, and you can take 5 divided by 32 for the first one, and you find out 5 divided by 32 comes out to 0.15625. That's over, but it's a little bit, quite a bit over. I mean, more than we might need. So let's try the other fraction, which is 9/64. So 9 divided by 64, and that comes closer. It's 0.140625. So the answer is 25 and 9/64. Now let's talk about how to figure out the displacement of an engine. Now the displacement is how much space the piston takes when it moves up and down in the cylinder. You can figure out the displacement for one cylinder, and the way you do that is you take the area of the circle made by the top of the piston and multiply it times the stroke of the piston, or the height of the movement, and that tells you the displacement for one particular cylinder. Multiply that times the number of cylinders, and you've got the displacement for the whole engine. Let's take a look at the formulas for that. First of all, the area of a circle is pi times the radius squared. So if you can find the area of this circle at the top of the piston by taking pi, which is 3.1416, and multiplying it times the radius squared. Now, the radius is from the center of the piston out to the end, or out to the edge. Very often, they'll give you the entire bore, the entire diameter of the piston. They call that the bore when you're talking about a piston. And so if you get the bore of the piston, you have to take that diameter and divide it by 2, and that gives you the radius. And so let's take a look at the displacement then for a particular cylinder. Would be pi times the bore, which is the diameter of the piston, divided by 2. You square that because it's pi r squared, times the stroke. And if you want it for the entire engine, then you'd multiply it times the number of cylinders in the engine, and that would be the displacement for the entire engine. Now let's you and I take a look at the way they're going to ask you a particular question about this. They're going to say, what is the displacement of a piston that has a 1.5 inch diameter bore and a stroke of 4 inches? So let's see, 1.5 inch diameter, but that's a bore, and so half of that would be 1.5 divided by 2. So you take pi times the diameter divided by 2, and then you square it, and then the stroke is 4 inches, so times the stroke, which is 4. And so again, it's 3.1416 times, and 1.5 divided by 2 is 0.75. Let's do that with a calculator real quick just to make sure you know what we're doing. And we'll take the 1.5 divided by 2, and you get 0.75. Now, we're going to square that later on, so let's go ahead and multiply that time itself times 0.75, and we'll see what that is squared, and we get 0.5625. So now we have 3.1416 times 0.5625 times 4. So if you want to go ahead and just multiply all those out, we can find out what the displacement is. 3.1416 times 0.5625 times 4. And the displacement then works out to be just about 7.0686 inches. Now that's the displacement of one cylinder. Let's you and I figure out the displacement of a 4-cylinder engine. They're going to give you a question that goes like this. Let's take a look at it word for word. They say a 4-cylinder aircraft engine has a cylinder bore of 3.78 inches. And the cylinder is 8.5 inches deep. Now with the piston on bottom center, the top of the piston measures 4 inches from the bottom of the cylinder. What is the approximate piston displacement of this engine? All right, now let's take a look at it. First of all, you take pi, and remember this particular cylinder had a bore of 3.78. Let's you and I use the calculator and find out what the radius of that piston is. So you take 3.78 divided by 2, the bore is the diameter, divided by 2, and we find out the radius is 1.89. That's how we got that 1.89. So you take pi times the radius, which is 1.89, and that's squared. Now, if you remember, they said the piston on bottom center, the top of the piston was 4 inches from the top of the cylinder. And when it's the whole cylinder is 8.5 inches deep, so what that tells you is the displacement is 8.5 inches minus 4 inches, or the stroke is 8.5 inches minus 4 inches. And there are 4 cylinders in this engine. So now let's continue with this. You have pi, which is 3.1416, times 1.89 squared. So let's just multiply 1.89 times 1.89, and you're going to find out it comes out to 3.5721. And now you take the 8.5 minus 4, and you find out the stroke is 4.5 inches. And there are 4 cylinders. So we have to multiply all those things together. So let you and I go ahead and multiply all those things together, and we'll figure out this displacement for this entire engine. Okay, let's use the electronic calculator. 3.1416 times 3.5721 times the 4.5 times the number of cylinders. Stroke is 4.5, number of cylinders is 4, and we get a displacement of about 202.99, 202 cubic inches. Obviously, too easy for everybody, so let's once again, you and I do another one. This time, let's assume we have a 6-cylinder engine with a bore of 3.5 inches, that's the entire diameter, a cylinder height of 7 inches, and a stroke of 4.5 inches. Now, it's a stroke that counts. What will be the total piston displacement of the 6-cylinder engine? Well, once again, it's the number of cylinders times pi times the radius squared times the stroke. And so the number of cylinders is 6, pi is 3.1416. And once again, we'll have to take that 3.5 inches, which is the bore, and divide by 2. So let you and I use the calculator and take that 3.5 inches and divide it by 2. So we punch in 3.5, we divide by 2, and I get 1.75. And that's the radius of that piston, and we want to square that, so let's go ahead and multiply that times 1.75. And we get, when we do that, 3.0625, and of course times 4.5 is the stroke. So now, if you look at this information, 6 cylinders times pi, which is 3.1416, times the 3.0625, which is the radius squared, and then times the stroke, which is 4.5. So let's multiply all of that out with the calculator so we can do it right away. 6 times 3.1416 times 3.0625 times 4.5, and the answer is 259 7/77 cubic inches, and that's how they're going to ask you about that on the test. Now, let's you and I talk about ratios, and the questions are going to ask you about ratios on the FAA written exam. Now, a ratio is a relationship of one number to another, and what you do is divide one number by the other, and it makes a fraction. Then you reduce that fraction to its lowest common denominator, and that'll be your ratio. Now, a typical ratio that you use in real life as a mechanic, of course, is a compression ratio. And here's how the compression ratio works. When the piston's at the bottom of the cylinder, you have a certain amount of space available inside that cylinder. And then when the piston's at the top, you have much less space available in the cylinder, and the ratio between those two spaces is the compression ratio. So here's the way they're going to ask you the question. They're going to say the volume of a cylinder with the piston at the bottom is 84 cubic inches. That's the volume here with the piston at the bottom. Then they're going to say the piston displacement, the amount of travel, that's the stroke, times the area of the piston, stroke times the area of the circle at the top of the piston, is 70 cubic inches. And so the question is, how much space is there left at the top? Well, at the top is 84 minus 70, or 14 cubic inches at the top. So when the piston's at the top, you have 14 cubic inches left. It's that 84 minus 70. And when the piston's at the bottom, you have 84 cubic inches. So the compression ratio is 84 to 14. Now, you need to reduce this to the lowest common denominator. And you do that by dividing by whatever number you can see until you can't divide anymore. Let's see if we can divide by 14. So let's you and I get out the electronic calculator. And there it is. And we'll take the 84, divide by 14, and what do you get? And son of a gun, you get 6. So 84 divided by 14 gets 6. 14 divided by 14 gets 1. So this compression ratio of this engine is 6 to 1. And that's an exact question about this on the FAA written exam. Now let's take a look at another one. They're going to say, what is the ratio of 10 feet to 30 inches? Now, the thing you need to recognize about this won't work until you get them both in either feet or inches. Let's convert them to inches. So here we have 30 inches, but 10 feet doesn't work, so we multiply that times 12 to make it inches. So it's 10 times 12, and that's 120 inches to 30 inches. So the ratio starts out being 120 inches to 30 inches. But once again, you have to try and get this ratio to its lowest common denominator. So we want to divide by something to get down to 4. Let's divide by 30. 120 divided by 30. Let's try that with a calculator real quick. And we'll take 120 divided by 30, and that comes out to 4. So 120 divided by 30 equals 4. 30 divided by 30 equals 1. So this ratio is 4 to 1. And by the way, that can be expressed 4 to 1 like so, or 4:1. And it's exactly the same thing. It's a ratio of 4 divided by 1. Now here's another one. They're going to say, what is the ratio of a gasoline fuel load of 200 gallons to one of 1,680 pounds? Now, what you need to recognize again is you have to get everything in the same terms. You either got to talk in pounds or got to talk in gallons. Let's convert everything into pounds. The big load is 1,680 pounds, and the other one's 200 gallons, and fuel weighs, and you need to know this, they don't tell you this, 6 pounds per gallon. So you multiply 200 times 6 and find out that there's 1,200 pounds in the smaller load of fuel, 1,680 pounds in the bigger load of fuel, and the ratio is 1,200 to 1,680. Well, now we have to divide by something, so let's try the calculator again and see what we can do. We'll take the 1,200, punch in the 1,200, and let's try dividing it by 20. We'll divide each of these. You have to divide top and bottom by the same number. We'll try that. And I got 60. Now let's try the 1,680 and see if we can divide it by 20. You have to divide both the top and bottom by the same number. And I got 84. So now we have a ratio of 60 to 84. Well, that can still be brought down to a lower common denominator. So let's see if we can't divide by 12. 60 divided by 12, and see what we get when we do that. And son of a gun, we get 5. Let's divide 84 by 12 and see what we get when we do that. And I get 7, and I get 5/7. Now, there's nothing else I can divide both the top and the bottom by, so I have that fraction in its lowest common denominator, and therefore the ratio is 5 to 7, and that's the answer on the test. It could be written 5:7. Now, here's another one they're going to ask you. They're going to say, what is the speed ratio of a gear with 36 teeth meshed to a gear with 20 teeth? All right, you have 36 to 20. All right, now what we have to do is try and reduce that to its lowest common denominator. You can divide by 2, and I can do that in my head real quick. 36 divided by 2 is 18. 20 divided by 2 comes out to 10. And I could divide by 2 again. 18 divided by 2 is 9. 10 divided by 2 is 5. And the ratio can be 9:5 or 9/5 or expressed 9:5. Those are 3 ways of expressing a ratio right there. And it's 9 to 5. And actually, literally, the speed would be 5 to 9. Because the one with the most teeth, the gear with the most teeth goes the slowest, the gear with the least teeth goes the fastest, so technically the ratio would be 5 to 9, but on the test when they ask you this question, they express it as 9 to 5. Now here's another problem that's really pretty simple, and it has to be. It's the kind of problem that pilots have to work out. So let's take a look at it. It says you have an airplane flying 750 miles and it used 60 gallons. Well, that tells you your fuel rate right there. And it says how many gallons will it need to go 2,500 miles. Well, one way to solve this problem is with a proportion. And if you remember from way back in grade school and high school, a proportion is a statement of equality between 2 or more ratios. We'll use 2 ratios in this case. And you actually have 2 ratios. Let's take a look at it. First of all, you flew 750 miles, used 60 gallons. If you state it like this, it'll make sense. And then that's equal to this ratio of 2,500 miles to how many gallons. So you know that if you have the same fuel rate, these ratios will be equal to each other. So you set the problem up like this. 750 miles is 60 gallons, then 2,500 miles would be how many gallons? Now, dredging way back into the deep recesses of your memory, you might just remember to solve this problem, all you have to do is cross multiply. You multiply the gallons times 750 and the gallons times 2,500, in this case 60 times 2,500. So let's do that. What you would find out is the number of gallons times 750 is equal to 60 times 2,500. So to solve this problem, you cross multiply, and now all you have to do is divide each side by 750. So it works out the number of gallons is equal to 60 times 2,500 divided by 750. And once you have it down like this, it's just a calculator problem. So let's whip out that trusty old calculator and multiply 60 times 2,500. And then we get an answer and divide that by 750. And you're going to find out how many gallons it takes to go 2,500 miles, and the answer is 200 gallons. So once you can remember to set this up as a proportion, 750 miles and 60 gallons, 60 miles using 60 gallons, 750 miles, how many gallons would you use 2,500? Set it up like that and cross multiply, and you've got it figured out. Now let's take a look at another way they're going to ask you questions about ratios in the test, and it has to do with gear ratios. The thing you need to know is, let's assume you have a 14 teeth gear, that's a small gear, driving a big gear which is 42 teeth. Well, the small gear will have to turn faster than the big tooth gear. And so the ratio is you take the teeth driving, and that'll be a small number, but the RPM that it drives at will be a big number. So you cross these. The teeth driven will be a big number, but the RPM that's driving it will be a small number. So you see, when you're working with gear teeth and gear RPM, you cross the ratios here so that you have driving on top on this side and driving on the bottom on that side. And that's the thing for you to remember about that. Now the question they're going to ask you is, let's assume that you have a 14-tooth gear or teeth gear driving a 42-teeth gear. And let's assume that the 14-teeth gear is going at 420 RPM. Well, this is the driving one. So the driving goes on the top here, and the driving goes on the bottom here. The driven is on the bottom here, and the question is, what speed will the 42-tooth gear go at? And we know it's going to go slower than 420 RPM. So here is the proportion like so. And you need to remember this cross situation because that'll be important for you on the test. Now, let's figure it out. All we have to do is cross multiply, and so 42 teeth times the question mark RPM equals 14 teeth times 420 RPM, 14 times 420. All right, and all we have to do now to get the RPM is divide each side by 42, so we'll take the 42 off of this side, and it's 14 times 420 divided by 42. Now let you and I use the electronic calculator and see if we can figure out some of this. And to do that, what we're going to do is we're going to multiply it out, and it's 14 times 420 divided by 42. And we get 140 RPM. The 14 times 420 came out to 5880. Before we leave the subject of gears, let's you and I get some gear terminology straight. And that terminology is pinion gear and spur gear. Well, if one gear is driving another one, one's smaller, one's bigger, the pinion gear is the smaller gear, and the spur gear is the larger gear. And that's a matter of terminology. Unfortunately, you do need to know for the test. All right, now let's talk about fractions. And what we want to do is convert fractions into a percent. And all you have to do is do exactly what it tells you to do. If you see 5/8, divide 5 by 8. So let's whip out the calculator and divide 5 by 8. And you take 5 divided by 8, and you see 5/8 is 0.625. And if you want to make it a percent, move the decimal point 2 places to the right, and it's 62.5%. And that's exactly what they're going to ask you to do in the test. So let's do another one. Let's take a look at 7/8. And you take 7 divided by 8 on the calculator. So 7 divided by 8. And you get 0.875. Move the decimal point 2 places to the right to make it a percent, and you get 87.5%. All right, let's do another one. They're going to say, okay, let's assume that you have 65 divided by 80. What percent is it? Well, 65 divided by 80, and you get 0.8125. Move that decimal point 2 places to the right, and you get 81%. Now, you folks have all of this stuff just nailed, so let's do another kind of question. In this case, you have a part that has a maximum design life of 1,100 hours, and they took 15 aircraft that they had to remove that part, presumably when it failed, from the aircraft, and they took the average life of that part in real life, and they found out it came out to 835.3 hours. So the question is, what percentage of the maximum design life has been achieved by these parts? Now, let me ask you a question. First of all, what does the 15 have to do with this? And the answer is absolutely nothing. It's there to confuse you. It has nothing to do with your calculation. It just tells you how many airplanes they used to get this average. So let's figure out what percent it is, and all we have to do is do a little bit of math. First of all, we're going to take the 835.3 and divide by 1,100, and when you do that, you get this expressed as a decimal. So it's 835.3 divided by 1,100. And we're going to get a decimal of 0.7593636. Now that's the decimal. We want to convert that to a percentage. All you have to do is move the decimal point 2 places to the right or multiply times 100. And when you do that, it's 75.9%. So what we found out is these parts are only achieving 75.9% of their design life. Now let's take a look at a few other percentage problems. Let's assume an engine has 98 horsepower maximum and it's running at 75% power. What is the horsepower being developed? This is pretty simple stuff. Let's take a look at it. All you want to know is 75% of 98 horsepower, so it's 0.75. Move the decimal point 2 places to the left. 0.75 times 98 horsepower, and let's use the electronic calculator. 0.75 times 98.
And when you do that, you get 73.5. Trying to get my head out of the way. 73.5 there. Now let's take a look at another percentage problem that also happens to involve proportions. And it works like this. We've got an engine running. And boy, am I uncomfortable standing this close to this engine. But we have an engine running here. And they're going to tell you that this engine is turning at 1965 RPM. Now, who read this tachometer to get exactly 1965? I don't know. They're better at reading tachometers than I am. But that's what the FAA gave us, so that's what we'll use, 1965 RPM. And they're also going to tell you that at that RPM, this engine's putting out 65% power. Now, the question is, what is the maximum RPM? Now, we're going to assume the maximum RPM would come at 100% power. In that case, this would be just a proportion problem. Here's the way we'd set it up. We'd say that 1965 RPM is to 65% power, as maximum RPM is to 100% power. And that's the way you'd set up your proportion. Now, all we have to do is cross multiply. We take the 65 times the maximum RPM, put that on the left-hand side, and take the 100 times 1965 and put that on the right-hand side, and we're all set up. Now, all we have to do now is divide both sides by 65. To do that, we'll cross off the 65 on the left-hand side, and on the right-hand side, we'll take the whole expression and put it over 65, and now we've divided both sides of the equation by 65. To solve the problem, all we have to do is whip out the trusty old calculator and multiply all this out. It's going to be 100 times 1965 divided by 65. And we find out that our RPM, the maximum RPM, or the 100% RPM, is 3,023 RPM, and that's all there is to this proportion problem. All right, now let's do one more. An engine develops 108 horsepower at 87% power. What horsepower would be developed at 65% power? Well, we could do this a lot of ways. Let's make it a proportion. 108 horsepower at 87% equals what percent horsepower, or what horsepower actually at 65%? We cross multiply. Percent horsepower times 87% equals 108 horsepower times 65%. Now we divide each side by 87%. Percent horsepower equals 108 horsepower times 65% divided by 87%. All we have to do is use the electronic calculator, so let's do that. And we'll take that number there, we'll multiply the 108 times 65 divided by 87, and you get 80.689, we'll call it 69 horsepower. So those are the kinds of questions they're going to ask you about percentages. Let's do another one. Let's assume, and this is the biggie right here, this has to do with money. The parts department profit is 12% on a new magneto. Now, I don't understand why they ask this, because no one ever has trouble figuring out their profit. But the question is, if your profit is 12% on a new magneto, how much does the magneto cost if the selling price is $145.60? Well, let's take a look at this. 100% of the cost plus 12% is $145.60. We know that's 112% of the cost is $145.60. Let's assume we want to know what 1% of the cost of that magneto is. Just divide each side by 112. So 1% of the cost is $145.60 divided by 112. 100% of the cost is $145.60 times 100 divided by 112. Or if you do that with your electronic calculator, and let's do that real quick, you take 145.60 times 100 divided by 112, and you get the original cost. 100% of the cost of that part was 130. Now, another way you could do this is take 145.60 and divide by 1.12. Let's do that real quick. 145.60 divided by 1.12. And son of a gun, you get 130, and that was the original cost of that part. And you, I am sure, in spite of what the FAA might think, know well enough in order to figure out whether or not you're making a profit. And believe it or not, that is the most important thing, in spite of the FAA, you need to know about mathematics for the A&P.